Bandsaws are versatile in that they can cut curves, cut straight lines, and cut at angles. Compound cuts can be performed through a combination of a tilting table and a miter guide. Bandsaws excel at resawing, where a large board is sawed into thinner slices. Resawing is unique to bandsaws. Bandsaws incorporate a blade guard which adjusts vertically and covers the exposed part of the blade except for that which is necessary for cutting. Only the two-wheel bandsaw is discussed in this lecture, as it is the most common model. The bandsaw consists of two large diameter wheels where a continuous blade rotates. The blade is tensioned onto the wheels and the lower wheel drives the assembly through a motor. The bandsaw blade rotates clockwise to cut on the downstroke. The teeth in the blade move downwards toward the workpiece and as a result keep the workpiece on the table. Shown is a fairly common model of bandsaw. The 14-inch bandsaw size can be considered the standard in bandsaws. This bandsaw has had an upgraded motor installed as well as a riser kit. The riser kit increases the throw capacity from 6 to 12 inches. A larger 1 horsepower motor is necessary to power through wider boards. Dust collection is vastly improved on this bandsaw with dust ports beneath the table and at the bottom of the lower wheel. These areas collect the most fine dust. The fence is also upgraded from the original fence. This fence excels at resawing. Shown here is the upper wheel of a typical bandsaw. The metal wheel has a rubber tire fitted to it. The bandsaw blade rides on tires on both wheels. Tracking is critical where the blade needs to be centered on the upper and lower wheels. The technical term for this tracking adjustment is to make the wheels coplanar. The tension adjustment wheel can also be seen above the wheel, which maintains the correct tension on the blade. Shown is the lower wheel assembly. The lower part of the bandsaw also has a lower blade guide assembly. The blade travels in this assembly, which consists of an adjustable blade bearing and blade guide blocks. This guide is adjusted to have the blade tracking correctly. Dust collection ports can also be seen here. The continuous bandsaw blade has a set of teeth on one side, which cut on the downstroke. The blade rotates towards the workpiece, pushing the work onto the table. This makes a bandsaw inherently safe to use. The distance between the blade and the vertical frame determines the capacity of the bandsaw. As an example, this distance is 14 inches for a 14-inch capacity bandsaw. A belt or direct drive motor powers the lower wheel. The top wheel is adjustable left or right, so it can track the lower fixed wheel correctly. The blade guide system keeps the blade from wandering. Blade guides include adjustable back and side guides. All bandsaws include an upper blade guide. The better bandsaws also include a lower blade guide. Shown is the upper blade guide system. A bandsaw table tilts up to 45 degrees to the right. The size of a bandsaw usually determines the power, as the motor rating is selected for the size of bandsaw. Accessories for a bandsaw include a miter guide and upgraded fence systems. The blade support bearing prevents the blade from being pushed too far back. A small 1/64 inch clearance is necessary between the blade support bearing and the blade. The blade is guided from side to side either with bearings as shown or with small phenolic blocks. The blade is inserted into the bandsaw through a slot in the table. A leveling pin ensures that the table remains flat. Shown is the upper blade guide assembly. Adjustments for the back or blade support bearing can also be seen. The adjustable phenolic blade guides which keep the blade centered can also be seen here. Higher quality bandsaws have bearings in place of these phenolic blocks. Another view of the upper blade guide assembly is shown here. The locking knobs for the blade support bearing and the blade guide blocks can be seen here. The blade guide is designed to be raised or lowered so it is just above the workpiece being cut. The lower blade guide assembly is shown here. This blade guide is similar to the one above with similar components and adjustments. The lower blade guide is located directly below the bandsaw table. The blade bearing is behind the blade. Knobs for the adjustments can also be seen. The phenolic blocks which keep the blade from moving side to side are also adjustable. Bandsaw blades are subject to a great deal of stress. The small radius of the bandsaw wheels combined with the tight radius of some cuts combine to create considerable stress on the blade. For this reason, blade tracking needs to be verified often to eliminate undue tension on the blade. Blade sizes are available in different widths and lengths. As well, many different tooth patterns are available for different applications. As an example, resawing needs larger but fewer teeth to quickly remove large amounts of wood dust while resawing wide boards. Resawing also demands a wider blade to deliver the maximum beam strength to the cut. Since resawing is essentially a straight cut, a wide blade does not introduce any problems. With regular curved cutting, however, a wide blade directly impacts the radius capability of the blade. For this reason, narrow width blades are selected when tight radii are being cut into a workpiece. Thin blades in a fine tooth pattern are ideal for regular, smooth sawing. Thicker blades with wider set and fewer teeth provide less opportunity for binding in a cut. Blades are therefore available with different TPI, or teeth per inch. Single-speed bandsaws rotate in the range of 2 to 3,000 fpm, or feet per minute. The necessary speeds vary when cutting either softwoods or hardwoods. Most bandsaws have a motor and pulley system to provide this range of speed. In fixed-speed bandsaws, if the wood being cut is very hard or dense, the feed speed can be reduced. This is the speed at which the board is being fed into the blade. To avoid premature blade breakage, it becomes important to periodically check adjustments and blade tension on a bandsaw. The workpiece should never be forced into the blade. Keep the upper blade guide to just above the workpiece being cut. Major adjustments on a bandsaw involve blade tensioning and blade tracking. The blade guides need to be adjusted or checked with every blade change. Blade tension is important. Too tight a blade can be as much of a problem as too loose a blade. Most bandsaws have a built-in tension scale. The blade can also be adjusted for tension by checking how taut it is or how much flex it has. The tension adjustment system can be seen here. This mechanism effectively raises or lowers the upper wheel in very small increments. This mechanism also incorporates a spring to maintain tension. The upper wheel also tilts left to right to adjust the tracking of the blade. This adjustment is performed with the adjustment screw seen protruding horizontally from the block. The blade tracking adjustment is performed by withdrawing the blade guide so no contact with the blade is made. The blade is then checked to see if it tracks correctly in the center of the upper and lower rubber tires. The blade should not be close to the rim of the upper or lower wheels. The bandsaw table should also be verified that it is in fact square to the blade when set to 0 degrees on the tilt scale. Once these adjustments are completed, the blade guides can be adjusted to ensure the blade is centered between the guide blocks and at the correct distance from the blade support bearing. An engineer square or small square is used to verify if the bandsaw table is square to the blade. The table needs to be perpendicular to the blade to ensure that cuts are vertically straight, especially when resawing. Once this adjustment is confirmed, the table is locked into position. Sharp blades should always be used. Dull blades will demand that more pressure be applied to the workpiece, possibly causing a dangerous situation. Blades should be inspected for metal fatigue and cracks. The upper blade guide should be 1/4 inch above the workpiece. Hands should be well away from the cut line. One hand is used to feed the work, while the other hand guides the work in normal operation. A safety shoe with a rubber sole should be used when feeding a board into the blade vertically. This keeps your hand isolated from the blade area. Bandsaws excel at creating duplicate parts. A block of wood parts can be stacked together, and with one cut, many parts are then cut. Bandsaw cuts are best when they are continuous without stopping. Planning the cut is highly recommended. Allowing for relief cuts helps where the radius of the cuts is tight. Relief cuts remove wood so the blade can turn around a corner or curve. Backtracking can be used to help release the blade from a cut just created. Backtracking should only be performed on straight cuts and not on curved cuts. Shown is the use of a miter guide. A miter guide allows a board to be crosscut at 90 degrees to the blade. Miter guides have adjustable angles in one axis. When this angle is combined with a tilted table, a compound angle can be created. Shown is a bandsaw table tilted at 45 degrees to demonstrate the creation of miter cuts at the end of a board. It is much better to measure the table tilt angle with a protractor or measuring tool instead of relying on the angle scale of the bandsaw. When resawing, a tall fence is critical to the accuracy and straightness of the cuts. The table is set to absolute 0 degrees to ensure that vertical cuts are parallel to the blade. The tall fence also provides support to a wide board. Feed speed should be lowered when wider boards are being resawn. The bandsaw table is set to 0 degrees here. A board is being resawn while pressed against the tall fence discussed previously. Another factor in determining feed speed is the hardness of the wood. Denser woods will need to be fed slower through the blade. Visualizing a cut before actually performing it is critical to a smooth and safe cut. Techniques such as relief cuts and backtracking can be used to accomplish this. Relief cuts are used to move around a tight curve. Backtracking is used to clean out a cut so you can continue. Bandsaw cuts usually follow a pattern drawn onto a workpiece. It is best to go slowly and stay just outside the marked line to allow for slight wandering in the cut. Any extra wood can be sanded down later. Curved work is usually performed freehand without the use of a fence.